So a little bit about me. I'm a 1992 graduate of Clemson University, bachelor's in civil engineering. I founded CCAD Engineering in 1999. That company was acquired by Davis & Floyd, which is a larger civil engineering firm in South Carolina, in 2018. In 2013, I invented the Marlee float skimmer and founded SW Products. We rebranded as Rymar Waterworks in 2018. I am a licensed professional engineer in South Carolina, North Carolina, and Georgia, a member of ICA, ASTM, and CESWA. So the main point here is I have been doing engineering for about 27, 28 years, and hopefully understand a lot of the things that you go through, and intend to make this a presentation to be very helpful for you in your day-to-day work. So today what we're going to focus on are skimmer sediment basin design. We're going to have the objective of just first making sure you understand what a skimmer is and why it is used. We'll talk about basic fundamentals of skimmer basin design, and specifically go over the Ohio EPA skimmer basin design tool, as well as our own Marlee float skimmer modeling tool. And then we're going to end up going over some advanced skimmer modeling for hydroflow and hydrocad, in case you want to utilize the skimmer for permanent use or need to run pre versus post design flows and incorporate the skimmer into that design. This presentation will also be available on YouTube after this. So if you have any colleagues, or if you just want to go back and get a refresher, once this is completed, we will upload it to our YouTube channel, and it'll be available to view there. So traditionally you had ponds without a skimmer. They would withdraw water from the bottom, and that's where the sediment accumulations are the highest. So in this case, you had a hole down at the bottom that obviously is taking in a lot of mud. You also had a filter ring in front, and you can see is how much mud is in this basin. That filter ring is probably sealed off at the front of it. So sediment basins with a skimmer, I'm trying to get rid of that laser pointer. Sediment basin with a skimmer withdraws from the surface or near the surface. It allows sediment to settle to the bottom of the pond. The Marlee float in particular takes water from about 8 inches to 16 inches below the surface. This advantage to that is that it excludes trash and debris that are floating on the surface and keeps that from entering the orifice and clogging the skimmer. Also, if you were to have a diesel spill during construction or something like that, that would not be readily discharged by the skimmer. It would be trapped in the basin. There are a number of skimmers out there. The Faircloth skimmer was probably the original. We have the Erosion Supply skimmer, Marlee float, and the IAS skimmer. And there may be a few others out there. I know the Delaware skimmer is one that is sometimes seen and is also included in Ohio's design sheet. So most states' construction general permits have a requirement for surface withdrawal, and the most common and cost-effective way to meet this is by using skimmers. And the CGP typically has a statement that says, when discharging from sediment basins, utilize outlet structures that withdraw from the surface unless infeasible. And in generally, there are rare circumstances that is infeasible. For those of you in, say, the northern parts of Ohio, you may have some severe winters and frozen conditions, and that could be a time where it's not feasible to leave the skimmer in the basin. I'm sure we have some folks on here that do work outside of Ohio and other areas. So currently, there are about 30 states that have surface withdrawal requirements. It is something that the EPA is adding as they continue to renew construction general permits. And so even if there's not currently in the state, it's likely it'll have it over the next few years. And I've got a couple of polls we may try to do, but I'm not sure how well they're going to work on the webinar. So we'll get to those in a few minutes. So first we're going to go over just the basic fundamentals of skimmer sediment basin design. And that's the basics are volume, time, and flow rate. So the first one is basin volume. So the basin volume is based on the regulations in your area. A lot of states have a standard of 1,800 cubic feet. Some say 3,600 cubic feet. I know for Ohio, the typical is 1,800 cubic feet as far as your dewatering volume. And then Ohio also has a requirement to have a permanent pool volume or sediment storage volume that's not drained by the skimmer. So for example, if the you had an 8-acre site and the requirement was 3,600 cubic feet, obviously your required volume is 28,800 cubic feet. It is really important to note the required volume versus the actual volume. The one mistake that we have seen that's common is when you're sizing the skimmer, you would use a provided volume, which in some cases, if your basin is going to be used for post-construction, that actual volume may be 2 or 3 times what the required volume is. And if you use that, you would actually drain the required volume too fast and quicker than you need to. So the second fundamental is dewatering time. So the basic premise is sediment basins work by allowing time for sediment to settle to the bottom. This time will vary based on the soil types. If you're in a sandy area, it's going to happen very quickly. If you're in silts and clays, it's going to take a little longer. So the general standard we see in many areas is 2 to 5 days. Ohio, the standard is 2 to 7 days. And note that your engineering judgment is needed to balance the time for extended detention times for maybe silts and clays versus if you're in an area that gets back-to-back rain events and you need that basin to have some volume before the next event gets there. So once you establish those two bases, the volume and the time frame, you can determine your flow rate required to drain the basin. And so you'll just simply use the basin volume divided by the dewatering time to determine that flow rate. And you'll use the minimum dewatering time to get for your maximum flow rate and vice versa, maximum time for your minimum flow rate. So for our example, if we had a 28,800 cubic feet of required volume, if we wanted to drain it in 2 days, that'd take a skimmer that would flow about 14,000 cubic feet per day. Or if we want to extend it on out to 5 days, you'd reduce the skimmer down to about just under 6,000 cubic feet per day. And something to note, a lower flow rate can often result in a smaller and less expensive skimmer. So if that's preferred, if you've got a real cost-conscious job, although the skimmer is not typically a major cost item for the project, you can save a little money that way. So one of the other key things to learn today is the need to specify flow rate and not just skimmer size. So this chart was taken from a study by TRI Environmental that they did for Georgia. They studied 3 different 3-inch skimmers. And so you see here they had a type 1, type 2, type 3. They didn't name the brands they had. Their test tank was 4 feet deep. And one thing to note is that all 3 skimmers had an increase in flow rate along with depth. So 2 of the skimmers started out pretty similar, around 37 gallons per minute, increased to just around 50 gallons per minute, while 1 skimmer had a flow rate nearly double the other 2, of 70 gallons per minute, and increased to about 90 gallons per minute. So the point is, if you just specify a 3-inch skimmer and don't specify what brand you're basing that on or the actual flow rate you're looking for, you may not get what you're looking for. Just an example of that, and as far as the increase in flow rate, this is testing that was done on our skimmers, and you can see how all of them have at least some sort of a flow rate curve. The smaller versions, that flow rate curve is minimal, while as you get to the larger versions, you can see a more pronounced curve, especially with our largest of the 4-inch with no orifice there. So I want to review a few state sediment basin standards. We'll focus on Ohio again, but it's always interesting just to give you some relative as far as how other states do things. So again, when it comes to basin volume, South Carolina has 3,600 cubic feet per acre, while North Carolina, Georgia, and Ohio all say 1,800 cubic feet per acre. If you're working in Kentucky, it's soil type dependent. So they actually make you calculate it based on the universal soil loss equation, how much volume you need to store the amount of sediment that's anticipated. For surface area, we've seen a couple of different ways to do that. So this 325 square feet per CFS of a 10-year storm in North and South Carolina. In Georgia, they have a different formula based on a 2-year storm. If you run the math on that, the numbers come out pretty close. Ohio doesn't really specify that. They just say they don't want it over 5 feet. So if you've got a large site, you end up having a large surface area, just, because you can't go over 5 feet in depth to get your volume. And again, in Kentucky, they have to calculate it based on the soil type and a basin ratio equation. The principal spillway, which is typically the skimmer and the riser structure. That riser structure may have other orifices above the required dewatering volume. Ranges from a 10-year standard to a 2-year, pretty consistent across the board there. And emergency spillway, kind of the same thing. That would be your, in addition to your riser, if you've got to accommodate a 100-year storm or 25-year storm, in most cases, design it for that. So where are skimmers required? In South Carolina and Ohio, they both say it's 10+ acres. They're both preferred on smaller basins. In North Carolina, they're required on just about everything. We've seen some large mud puddles with skimmers on them. In Georgia, they're preferred. They're not always required by, per their manual. There are some MS4s that actually require it, and Kentucky goes down to 5 acres. What we typically see is that if it's a basin, if it's actually got an outlet structure and a riser, then they want to see a skimmer. If it's true sediment trap that may have just a rock outlet, then they will let you get, obviously it'd be harder to put a skimmer in that if you're using discharge through a rock outlet. And that's typically done on, 2 acres or less sites. Dewatering time is another one that's interesting. And again, this establishes your flow rate. So North and South Carolina have a 2 to 5 day requirement. Georgia doesn't have a standard. They leave it up to the engineer. And Ohio says 2 to 7 days. And then again, in Kentucky, you have to calculate it. And we typically use a software called SEDCAD to calculate that. I'm not going to go into SEDCAD today since in Ohio, that's really not a prevalent software. But for those of you that do work in Kentucky that would like information on SEDCAD, please let us know. I'll be glad to send you a little short video on how to model a skimmer in SEDCAD, or to help you with any questions you have on that. But because we're focusing on Ohio today, we left that part out of the presentation. So this is from the Ohio EPA Stormwater Program website. I'm sure many of you are probably familiar with that. Oops. But this is the link to it. But rather than typing that in, just Google Ohio EPA Stormwater Program and it'll bring you here. So they have several tools and forms and all kind of stuff, information on there. What we're going to talk about is the sediment basin compliance spreadsheet that they offer. So if you scroll down on that page to construction activities and go to that tab and then click on this drop down for technical assistance and permit compliance materials. If you come down, you'll see, I don't know why it keeps jumping ahead, the sediment basin compliance spreadsheet. So this spreadsheet specifically states that Ohio EPA does not require or recommend a specific type of skimmer. Ohio EPA does not endorse or improve any of the proprietary devices, including the spreadsheet. So basically, we get a lot of questions, is the Marlee float approved? And the short answer is no, but Ohio EPA doesn't approve any devices. There are some, DOT sites that actually do, or some states that have approved lists, but Ohio does not. And Ohio DOT does not either. So it provides guidance for you. Again, we've got the standards 1,000 cubic feet for volume, 1,800 cubic feet for your dewatering. They do have the one watershed, the Big Darby Creek watershed, that requires 3,600 cubic feet. So if you're designing that, make sure you change that. Length width ratio, detention time, again, the 2 to 7 days, etc. So step 1 is your sediment basin volume. So you fill in your project information, fill in your sub-watershed total drainage area draining to that basin, and then Sorry about that. I've got some timings on here that evidently are still going. Fill in the disturbed area, and that will calculate your volume for your sediment storage. Then you can use their tool to fill in your basin stage storage. It'll confirm you're meeting your volume requirements, and it'll confirm for your sediment storage zone and your dewatering zone, and it'll plug in your elevations there. It'll check off, make sure you've met those requirements. By default, it's going to look at the Delaware DOT skimmer. This skimmer is a little bit different in that it has an orifice inside the outlet, and that orifice is controlling the flow, and the skimmer is just letting water into that orifice. So the skimmer itself doesn't control the flow, the orifice here does. But you plug in that information down here, and it'll tell you what size that orifice needs to be based on the head and the pond, and what it takes for your required volume. It has links to the ESC skimmer. It has links to the Faircloth skimmer for their online calculator. It has a link to the IAS water quality skimmer sizing PDF. And it also has a link, if you click Marlee float as a type, to our web page for our information. Because this is our webinar, we're going to go through our tool. So this is our design aid tool for a permanent pool. We give you a place to put in your engineer and project information. Over here, we let you put in your disturbed area and your drainage area. So this again helps, confirm what those volumes should be. And then you're going to use this area for your inputs. So this is your minimum and maximum time to drain, again, 2 to 7 days. Your pond depth, and that's going to be the depth to meet your required volume, not your total pond depth, so just the required volume depth. And then pond top length and width and bottom length and width. Now we know that very few basins are perfectly square or rectangular, so use your engineering judgment to adjust these numbers so that your calculated pond volume matches your required dewatering volume. It doesn't have to match exactly. Typically we say get within 5%, and that should be reasonable because again, we're trying to hit a 2 to 7 day time frame. Once you have that, go down to the bottom of the page and there's a skimmer report tab. When you click on it, it's going to take you to our Marlee float selection report. And so we'll confirm the required dewatering volume and the calculated volume match or are very close. It'll give you your minimum flow rate based on the maximum time, your maximum flow rate based on the minimum time. So now you've set a range for the skimmers that would work and meet your specifications. And then it's going to calculate the drawdown time for all of our skimmer configurations in each orifice. So you'll see each of our models has several different orifice configurations. All of those have been third-party tested to verify the flow rates. And you can plug that in and it'll tell you which ones based over here, based on your time frame you set, are acceptable. So in this case, we've suggested selecting the one at 70 hours. Typically, we try to hit around a 3-day time frame as a good, general rule. But you could up it, to a larger skimmer, or you could go to a smaller skimmer and adjust that drawdown time as you see fit based on the soil type. Then once you have that information, you just plug it back in to the Ohio EPA tool. And fill that out. And then we do recommend that you print out both reports, both the Ohio EPA report, excuse me, and the RIMAR skimmer selection report. That'll show that your skimmer matches your design and your EPA report. Again, it'll give you all the different skimmers that are acceptable, that fall within that time frame. And then when on your plans, you can specify which one you prefer, or if you want to give the contractor options on different ones. Oops. We also have basin details available. These have been developed through several states' standards. And so we have standard criteria here. This one includes the dewatering volume and the sediment storage volume requirements. And the detail shows you've got a sediment storage area below your outlet. So you'd fill this in for each basin. You want to make sure that you specify the required dewatering volume and your drawdown time frame on your plan set. So when you're filling this out, and these are pretty standard: drainage area, disturbed area, flow, all those items, skimmer information. Get over here to skimmer size and skimmer orifice diameter. And then because different skimmers of different brands flow differently, we have a skimmer type. You can specify whether an equal is allowed, yes or no. Typically that will be yes, but you may have certain situations where you need a precise flow rate for some standard, and so you may say no. But here you'll specify the flow rate range. And if you specify the dewatering time range here and the flow rate range here, and if a contractor does want to use a different skimmer, then as long as it meets that range, it's already been approved by the reviewer. And so hopefully it will minimize any re-review or resubmittals to do that. So that's one thing we do recommend, is specify this during the review time as a range rather than a precise time. And that way the review's already been done to approve that. So I'm gonna try this poll real quick. I don't know how well that comes up on your screen, but we've got 3 questions. And if you would just go through those real quick and enter what you can for me. It'll give me some idea of what our audience is today. We do have a good group on today. So I've got a little over 40 people on here, so give it just a minute or two to fill in your votes there. All right, so it looks like just about everybody's voted. So we've got a good range here. See if I can end the poll. I don't know if it'll show you the results. I think it will. There we go. So, and how familiar are you with skimmers? Looks like most of you are some or very. You've got a few that are just learning. How familiar are you with the Marlee float? You know, a few of you never heard of it until today, so we really appreciate you being here. Most of you, it looks like you've heard of it, and several have actually specified it, so we really appreciate you already specifying it as well. And then, have you considered skimmers for permanent use? A few of you have said yes, about a third or fourth, and most of you have said no. So we're going to talk about that here too. And here we go. I'll share those. Didn't realize I could share that, so we'll share the results with you. And we'll go through how skimmers can be used for permanent use and how that can be an advantage. All right. So I'm sure most of you have seen skimmers installed. This is actually installed in a dry basin. And in a dry basin situation, you need to have a skimmer pit rather than, you know, perched up on stone. Although in Ohio, you're typically going to have it perched up because you're going to have a permanent pool volume. This is one of the pictures that was sent to us by a inspector in the field, and he said something doesn't look quite right. Obviously, this is not how you install a skimmer. Skimmers need to float, and not going to be much floating with a hard pipe and no flexible coupling installed here. But there's not much room since they've got the valve open on this side of the outlet anyway. So anyway, you do see all kinds of strange things in the field. And then maintenance, you know, maintenance is required. It's a good sign if you ever see vegetation growing out of the skimmer, you probably have a problem. So this was an engineering project we have, and actually had about a, you know, root ball was filling the entire skimmer. So it wasn't much flow coming out of this thing. So the contractors are, in our area at least, and I'm sure in yours too, are kind of notorious for maybe not doing the best on maintenance sometimes. So we mentioned permanent use of skimmers. So I'm gonna give you 2 examples where we use skimmers permanently. And they definitely can help with maintenance as well as some other benefits. But this basin was one that had been overgrown for a number of years, probably 15 years or so before it was cleaned out. And we were working with the owner to get it cleaned up. And you can see here, you had these holes in the riser, but you had all this water and just trash and debris stuck in it. Well, we ended up having to redesign the basin. There was actually a small hole 6 feet below, go back, this muck line. So you can see here the basin's just about dried, but there's probably 2 feet of water here, and then another 6 feet below the muck, there was a 2-inch orifice that had been clogged up many, many years ago. So we ended up redesigning the basin. We closed these holes, we put in some holes up here, and we put in our skimmer for permanent use instead of that 2-inch orifice. Now the advantage here is this is a skimmer with a 5-inch orifice, and since it has very little head, had a flow rate very close to that 2-inch orifice with several feet of head on it. And we monitored it. It was a pilot project, so we had to monitor it for the first 12 months monthly to make sure it was operating correctly. Well, about a year to maybe 18 months into the project, we had a extremely large rain event, and it just so happened that it happened the same day that the landscapers were cutting the pond. So they had cut the sides of this pond and not gotten all the debris out. And then they got caught by a major thunderstorm, washed all of that debris. You can see all this debris down in the basin, but it still was able to drain. And several days later, you can see it drained out fully, and they got in here and got it cleaned out. So what you don't realize in looking at this structure, that structure is about 12 feet tall, 2 6-foot sections there. It has another 6-foot section down below the muck. So if that had gotten clogged, you would have to put a ladder out here, climb up, take off this huge trash rack, climb down in this structure to get down to almost 20 feet below the top to unclog a 2-inch orifice and try to get this thing to drain. So skimmers work much better. Even if it did get clogged, you can pull it over to the side, get to it very easily to unclog it. So a big improvement in the maintenance of this pond. This other one was in Charlotte, North Carolina. This pond also had been neglected for a number of years. When we first got there, the mud was up here, so completely covering the pipe. It was just a head wall in the dam. So we cleaned this out, took out all the muck here. You can see the dam and the spillway, got this thing really cleaned out. It is in a very natural area. It had a small stream that was flowing most of the time, not 100% of the time, but most of the time it had flow. But because this was a wetland natural area, it couldn't be disturbed. You had a lot of just debris and leaf litter coming down through here. So we cleaned it up and put in a riprap ring to try to protect it. But after every rain, you'd get this type of event with all this trash. Sometimes it would clog slightly, but still drain. Other times it would completely clog, and it would drain, take weeks for it to drain down enough to get it unclogged. So it became nearly impossible to keep the outlet flowing, and the depth of the pond made it very difficult to clear it whenever obstructions had it clogged. So we redesigned this pond. We put in a riser structure. We added a skimmer. The riser was designed to take, I think, up to the 25-year storm. The skimmer was handling basically the 2 to and maybe some of the 10-year storm. So put this in this particular case, Charlotte has a very large stormwater utility fee, and we were able to get this client about a 95% credit on their fee, which translated to about a $25,000 a year savings. So in doing this work, it also basically paid for itself within about 2 years, or less than 2 years, to get their cost back for going in and doing. So we have continued to monitor this. See, this is the time after a rain event. Got a lot of trash and debris in here, but it's still draining down. This is another event where you can see the storm had gotten up to the riser and gone over, but again, it was draining down. You will notice that pipe is pretty bowed. We had put in an HDPE pipe instead of the PVC pipe. And we found out over time, especially in hot weather, there was some sediment accumulated here, and the skimmer was sitting down lower, so it actually started to bow that pipe. So it affected the flow rate some. Whenever it got up a little bit, flowing better, it didn't really affect it. So we ended up swapping that out and actually going back with a PVC pipe. We were hoping the HDPE would work because it'd be more UV resistant, but we're just going to have to maybe replace that PVC every 5 years or so if it becomes an issue. So you can see there are some advantages to using skimmers permanently. So now we're going to talk about how you would design that. So first step is we're going to go through how you would model that in HydroFlow. So this is a specific project that we worked on a few years ago. And we're going to use HydroFlow to reflect the peak rate attenuation and how that would help with with your design, and how you'd actually model the flow of the skimmer in HydroFlow to model it accurately. So we've got a site here. It's about 5.5 acres. This area was staying undisturbed. This area was being disturbed. Had a sediment basin here. Had a study point that's here. This is an inlet structure, catch basin. This is a little side road, but there's no drainage on this side of the road. A little surprising the city didn't make us run drainage over to keep water from flowing across, but they didn't. And because we didn't want to increase flow and having liability or increase our liability for water in the road, we wanted to make sure we're detaining, even during construction, the flow there. So our pre-development was about 5.5 acres, curve number just under 60, time of concentration just under 20 minutes for our pre. For our post, again, the disturbed area is about 2.25 acres. We used a curve number of 86 for a bare earth disturbed clay, time of concentration of 7 minutes. And then the rest of the basin was undisturbed, so it basically had the same as the pre-development criteria. So the first thing you want to do is build your stage storage table. And you'll see here what we've done is for the stage and elevation, we've put in several data points. Now we did this to model the skimmer, so we put in a data point at 0.1, 0.3, 0.5, and then every half a foot up to 4 feet. And you do have to estimate your contour area at each one of those points. When you do that, it gives you a place to go back in and fill in your skimmer flow rate. So all of our skimmers on the detail will have a flow table, and it'll give flows at 0.1 through 4 feet, as well as just an average flow if you want to just use an average. But you simply take the flow rate at that depth and fill in the table. And so the way you do that is you build your outlet structure in HydroFlow. So A is our barrels. We had an 18-inch barrel going out and all the criteria with it. We had a orifice, a 6-inch orifice, about just under 2 feet above the bottom of the pond. The top of the riser was 3.6 feet total in height. And then we actually had a rectangular weir, so it's a complicated little outlet structure. But we didn't have a hole at the bottom. So normally you'd have, this B would be an orifice at the bottom of your riser structure. Instead, we're using this user-defined column. So this is the main point of how to model a skimmer, is you plug in the user-defined flow by pulling those flows off of our detail at each data point. So that's why you need to create the data point, so you have a place to put in the user-defined function. Again, we did this as a model, basically for presentation purposes. It's the most accurate way to model the flow rate curve, but if you feel like, every foot's okay or so, you just use your engineering judgment. You may not have to put in every data point there. So if your basin is over 4 feet deep, you can either use the same flow rate, because like we showed on the flow rate curves, it basically stabled out, or you can extrapolate it, or you can actually use our design tool. And I think I have a slide here to show you that you can plug in the depth on our design tool, and it will give you the flow rate at higher depths than 4 feet. But again, there's your user-defined flow in your flow rate table. If you look at a schematic in HydroFlow, you'll see there's no orifice here at the bottom. But if you look at your stage storage discharge, you're definitely getting discharge immediately. And a close-up view, this green line would represent the skimmer flow. So you can see the skimmer, you can see the 6-inch orifice kicking in, you can see the rectangular weir kicking in, and then the top of the riser kicking in up to top of the pond. And then when you look at your flow, you'll see total flow is matching your user-defined until you get up to the 2 feet, which that's where the 6-inch orifice kicked in at 1.75 feet, and so on. So when we ran this example, we had a pre of 2.33 CFS and a post of 2.5 CFS for the 2-year storm. And for the 10-year storm, we had a pre of 9.5 CFS and a post of 9 CFS. And so we actually got away with a slight increase during a 2-year, but about a half a CFS decrease for our 10-year. Oftentimes, if you're going to model, if you're using this during construction and you need to model the flow, you may need to determine that your basin is holding water for over the 48 hours to meet that requirement. So if you look at this one, in this case, the outflow stops about 29 hours, so well below the 48-hour time frame. And if you really look closely, it didn't fill up till 12 hours. It's really only discharging the basin in about 17, 18 hours from the time it gets full. The basin was full. You can see by our hydrograph that it's getting up to basically the top of the basin, so there's no extra storage available in it. And so since in this example, we didn't meet our 48-hour dewatering time, we decided we wanted to try it with a skimmer with a lower flow rate. So we plugged in a different skimmer with a lower flow rate. And yes, it did increase our dewatering time past 48 hours. It's about 66 hours, or if you back out the 12 hours, it's really about 54 hours from the time it was full. Again, the basin is full. But what happened when we reduced that skimmer size, for our 10-year storm, our flow rate actually went up by 1.5 CF, almost 2 CFS. Remember, we were at just over 9 CFS before in our pre, and now we're up at 11. So the point there being that even though we went to a smaller skimmer, which reduced that flow for the skimmer, it ended up not letting as much water out as quickly. And so water got higher in the basin, more of it over the top of the riser, and actually increased our peak flow rate. So if you're required to do quantity control during construction, then you may not want to allow equals on the skimmer or specify a shorter, a narrower range of flow rate that's available. Otherwise, you could end up in a situation where you're actually increasing your peaks. So we're also going to talk about HydroCAD. Not sure how many of you are familiar with HydroCAD. It is a program that's somewhat similar to HydroFlow. We have used it primarily in the city of Charlotte. The city actually told us that they preferred HydroCAD over HydroFlow. The one big advantage of HydroCAD is that it's a smaller company, and they have incorporated a number of proprietary products into their software. So the basic functions are the same when you're building your basin, building your outlet structure, very similar ways to do that. The difference is when you're building your outlet, you can go here and click on a special or user-defined outlet, and then click on this load from file button. And when you do that, it'll pull up a folder of proprietary products. And one of those is the Marlee float, and it'll have each one of actually this is the old models. HydroFlow is currently updating it to the new models, but it'll have each model with each orifice configuration picked in. So you simply just click which one you want, and it plugs it in for you. So instead of having to go in and build your data points like you did in HydroFlow, it actually fills it all in for you. It actually has an extrapolate function, so it'll extrapolate it on out. It's just a neat program that does a few other things that HydroFlow does not do. Again, if you want to check your time frame with that, just right click on your basin for this node report, and it'll show your HydroFlow hydrograph or your hydrograph in HydroCAD and confirm your time frame of discharge. Again, this one goes out to about 66 hours. So we're going to jump into a little bit of information about our product specifically. Before we did that, I wanted to see if anyone had any questions. If you do, feel free to unmute yourself and ask, and I'll try to answer that if there's any other technical questions before we get into some of our specifics. All right, not hearing any, we'll jump into a little bit about about us. So again, rymarwaterworks.com is our website. We're very proud of this website. We feel like it's one of the better ones in the industry, so we want it to be a resource for you. So on our website, we have the Marlee Float design spec cut sheet page. On this page, you'll find our design tools. So we have a standard design tool for dry basins. We have another design tool that includes the permanent pool, which we work closely with Ohio EPA in developing this tool. Also with the Cleveland and Columbus areas. Summit County specifically was involved, and a few other areas that we got feedback on before we published this tool, and had them confirm it was, giving the information they wanted to see. You can also download our details. They're available in CAD and PDF, as well as our cut sheet or installation instructions. There's no login, sign up, etc. required. They're all free for you without having to sign up for anything. These are our standard details. You'll see each detail will have the skimmer and each orifice configuration. So each skimmer comes standard with the orifice size, whatever pipe size that is going out. And then we also have an orifice plate here. And I'll show you in a second how that works, but it allows you to change the orifice size to different sizes. So that you can reduce the flow if needed. So I did have a question that came up. It's asked about HydroCAD. Currently shows model 1, 2, and 3. When will the new models be available in HydroCAD? We have sent those to HydroCAD. I'm not sure where their next update is. We also have those available that I can email. So if anyone would like those, we can send them to you, and you can just manually save them in that folder. And we have that readily available. So I don't have it on the website because it's not something that's asked for that often, but we'll be glad to provide that if anyone needs it. So, but again, our detail, talked about the orifice plate. The skimmer comes with everything they need except for the piece of pipe. Typically that's PVC. Like we talked about before, it could be HDPE. We have a flexible coupling that's it's a bellows style. It's almost like a Fernco style coupling, but it's extended and has bellows in it. For most of the skimmers, our 6-inch skimmer uses a little different type coupling. And then the one thing you want to make sure when you specify is that this pipe is about 1.4 to 1.5 times the height of your riser structure, which allows you to make sure the skimmer can float up to the top of the riser, and so it doesn't water doesn't come in over it, which would clog it and kind of go under that debris guard. So our project is a little bit different. It's made of HDPE. Most other skimmers out there are PVC products. There is a little bit of Schedule 80 PVC on it. We did upgrade to the Schedule 80 versus Schedule 40, so it does last longer, but that's very limited. There's really no moving parts, and we have designed this to be part of the permanent outlet structure. Again, we have this debris guard on the outside, so any floating trash debris has to go, water has to go under that, so anything floating doesn't get through into the orifice. This unique design does trap floatables. Because our skimmer sits a little lower in the water, it works in mild frozen conditions. I won't say it works in heavily frozen conditions because I understand that that may not be the case. This is the orifice plate. So you can see here this little short video, hopefully showing up well. Simply pull it up to remove it. We have this little metal nub in the middle to make sure that the orifice is centered. If you decide to change what size it is, it's very simple just to lift it up again, rotate it to whatever size you prefer, and then place it back over the nub, and it'll hold it securely in place, as well as make sure that the orifice plate is centered on the pipe going out. So just about all of our skimmers have at least 3 flow rates. Some have up to 5 orifice configurations, and all of them are third-party tested to verify the drawdown times. Our previous models, some of you may be familiar with them, did have an issue that if they weren't installed correctly, they could tip or twist. The new model that we've released earlier this year all the weight is shifted to the bottom, so it always stays level. It's always self-righting. As you can see from Aaron here in the test tank, where we do most of our testing, it's, you know, gonna, no matter what happens to it, hopefully you never see that happen in the field, but you know, it's going to return to level each time it does that. So we're really excited to have this new model out to eliminate any tipping or twisting issues. We also have a new 6-inch and 8-inch model. We have a custom designed float. This is about a 4 foot by 2.5 foot size, you know, overall dimensions. But this large float makes our 6 and 8-inch basically unsinkable. We did build in some handles for easier carrying and installation. And I will mention that we have the ability to do custom colors in this because it's a custom made product just for us. If you're looking at doing a permanent installation and you really don't want orange, or in some cases this will be black, our 6-inch version has an orange float, our 8-inch version has a black float, so you can easily tell them apart in the field. But if you wanted something different, if you wanted a green or a blue or something else, then we could do that for you as well. It would just take about a month or so to get that made. So, you know, if you've got, say, a high-end subdivision, you want to leave this in as part of the permanent outlet, but they really don't want something bright orange in their pond, we understand and we can help you. Just let us know, we'll work with you on that. You know, we have 6 models. We have a wide range of flow rates. You know, it varies. Our 2-inch with a 1/2 inch orifice has what was really a trickle at 250 cubic feet per day. I mean, it is really a slow flow rate there. Our standard 8-inch model uses a 6-inch pipe. You can see it varies anywhere from 50,000 cubic feet or just under 50,000 to just over 130,000. We also have a special order item. We have an 8-inch model that uses an 8-inch pipe instead of the 6-inch pipe between the skimmer and the outlet. This increases our flow rate up to almost 160,000 cubic feet, which is by far the highest flow rate of any skimmer on the market. So if you do have basins that need multiple skimmers, you know, our 8-inch, using an 8-inch pipe, it's a possibility to reduce that and maybe only need 1, or if you need like 4, you might only need 2. So it is a special order item. It takes us about 2 weeks or so to get those shipped out, just because we don't have a high demand for that, but do want to let you know it is available. And then we're really excited, wish this was a little further along, but I do want to mention it. We have research and development underway to test our skimmer with filter media. So we're developing a specialized filter to go around the skimmer. We're going to use the skimmer to pull water through this filter media, and we're testing a variety of products to hit at least 80, hopefully up as much as 90% TSS removal. And we also have the option of adding additional media to focus on special pollutants of concern, such as hydrocarbons, metals. We're working on phosphorus. That's a difficult one, but we're working on that as well. So keep an eye out on our website, and we'll be sending information out when this is ready as well. But hopefully by probably 1st of 2021, we will have this released. We do plan to get NJCAT certification. We are planning to test this following NJCAT protocols, so that hopefully once we have that, it will be readily accepted by your local agency. And then before we wrap up, we just got a few more slides here. We do have another product we want to introduce you to. We've got this as our VersaWattle. This is our HS, our hard surface model. We call it inlet protection that won't back down. So sure, many of you seen the erosion eels or other products that maybe are filled with rubber, sand, or stone. And when they get hit by traffic, they just don't last, and they can create a real mess on your site and often do a poor job of sediment control. We developed this product specifically to trap sediment, but also stand up to traffic. So it's particularly useful where you have, say, a new subdivision and you don't have your final asphalt surface down. So you've got a lip here between the curb and the asphalt. Well, if you have that, water's going to bypass the box and oftentimes go down to a low point that's just not designed to handle that when all the other boxes upstream aren't working. So this does a great job of trapping sediment, but also kicking the water over the curb into the catch basin. You can see here in this short video exactly how it works. This is right after a rain event. So you can see it's trapping the sediment, and the water that's going into the box is fairly clean water. Now, we don't have testing to show we're going to meet an 80% TSS or something on this, just because the flows are so variable. But this is a great, additional line of defense, and especially useful to make sure water's not bypassing your catch basins. And then the biggest advantage of this product is it's foam filled and it's designed to be driven over. So whether it's standard vehicular traffic, which can handle it and not cause any damage to the cars, or if it's a fully loaded dump truck that tends to have to get by and run over it, our product's going to stand up to many times being driven over and rebound and continue to work. So unique product out there. It is held in place on the asphalt by screws. So we have a we find a specialized coarse threaded screw for the asphalt, standard Tapcon kind of screws for the concrete, but it can be installed there. We do get the question of, hey, what about snow plows? And I'll just say it's not going to work well with a snow plow. So, if you're getting into a snowy season, you may need to go out and take them up if the road is going to get plowed, or else the plow is going to rip them up. But for most of the year, they can be very effective at helping keep the water from bypassing your boxes, as well as trapping sediment. So I want to thank you all for watching our Skimmer Sediment Basin Design webinar. To receive continuing education credit, we ask that you send an email to info@rymarwaterworks.com, or you can send it directly to Ryan. I believe he's been in touch with most of you about getting set up for this. He'll send you a very short quiz. I promise you'll pass. And then once you send that quiz back to us, we'll send you out a PDH certificate. He'll also, I believe we offered in this time for a lunch gift certificate. So he'll email that to you as well. Be glad if anyone has any other questions. You can use either the chat function, or if you want to unmute yourself and just ask a question, I'll be glad to take any.
Also, just to let everyone know, this has been recorded, and we're going to be putting it on our Rymar Waterworks YouTube channel. So it'll be on demand for you. We'll also be coming out with select little segment videos that will include a bunch of stuff about the Marlee float and different skimmer sediment basin design videos.
Yeah, so we're working on some specifics to, for the Ohio EPA tool, for the HydroFlow, for HydroCAD, and for SEDCAD. And so especially for those of you that may have an interest in SEDCAD, that we did not include that in this presentation today, keep an eye on our website and our YouTube channel for those. And in the meantime, if you have any questions, I'm happy to set up a little quick video conference, virtual, to walk through that. It's pretty simple, just 2 or 3 things you need to understand in doing that, but we're happy to help with that. All right, well, if anyone else has any other question or wants to chat, we'll be glad to take that. Otherwise, we greatly appreciate everyone joining us today. Hope you found this useful and can help you in your projects. We hope that you will consider specifying the Marlee float skimmer on your next project. We really do feel it's the best skimmer on the market, by far the most durable, and we hope that you find that it works well. Thank you all very much.
Jamie, this is Trent.
Yeah, hey, Trent.
Hey, I just wanted to let everybody know that we do have representation here in Ohio. My office is based out of Delaware, Ohio. So if any of you guys want to see a Marlee float in person or have any more questions, we can make ourselves available for that as well.
Yeah, Trent, I appreciate you bringing that up. And also to let you know, we sell through distributors. So Core in Maine is one of our primary distributors in Ohio. Ferguson is also one of our distributors, as well as Site Supply. So most of those guys, or several of those guys, ranches carry it in stock, and so it should be readily available. However, we typically have, except for that large one I mentioned, the 8-inch that uses 8-inch pipe, they typically ship pretty quickly, so we can get them out to your job site within a few days. Okay, well, it looks like there's no other questions or comments. Again, we thank you for joining us, and I hope you found this very worthwhile, and send us an email. We'll be glad to send you the quiz and get you the continuing ed credit out. Thank you so much.